Hello everyone and welcome to IP study lecture video. Today I'm going to take very interesting topic of this grade. You know what? The name of the chapter is Exponents and Powers. So before I tell you what are the topics that we are going to cover in this lecture, let me tell you the need of this chapter. Why this chapter is important for us, why it plays an important role in our life. So student, in order to understand that, let me take an example. So you must have seen in your science notebook the distance between the two planets, or the distance between the Earth and the Moon, or the Moon and the Sun, and so on. So here, let me take a figure for you. Let me write it down on the screen. Okay? So the weight of the Earth is 5970, 3 times 0, again, so how many times I have written these triple zeros? I have written 7 times, and beside that we have more numbers before these zeros. So if I ask you, will you be able to read this number for me? Will you? No. Even I cannot read this big number. So what I have to do for this? You know, students, in order to read, in order to compare, in order to perform operations on large numbers, we need to have something that will help us, because it is quite difficult for us to deal with this large number. Hence, we come to know that there is a need to know the powers and exponent concept, right? So before I tell you about this concept in detail, let me tell you the topics that we are going to cover in this video. So first of all, we will discuss what are exponents and power and how to express numbers in terms of their exponents and power. Secondly, we will discuss about if we have -1, then how it will behave or what will be the result with different exponents. Next, we will discuss about different laws of exponents, and towards the end of the session, we will discuss about the standard form of a number. So without wasting our time, let's start the session. So student, as I've told you, exponents are used to describe or to express large numbers. So how we are going to do that? Let's see through an example. So here I have a number 1000. Let me write it for you, right? I can write this 1000 as 10 into 10 into 10, isn't it? Because we know that if you multiply 10 3 times, you will get 1000. So instead of writing 1000 like this, what I have done, I have broke down this number into 10 into 10 into 10. So here, how many times this number 10 is repeated? 3 times. So how many times it is repeated? It is repeated 3 times. So what I will do? I will write 3 over here, the superscript, right? So when a number is expressed in this form, we called it its exponential form, where this 10 is called the base of the number and this is called the exponent of the number. Am I clear to you? Let me take another example for you. Instead of taking base of 10, let's take another example. Here I have 256, right? And it is asking me to write this number in power of 2. So what I will do? I will prime factorize this number, right? So let's do it together. Let me prime factorize it for you. So here I have 256, right? We will start with 2 because we have to write the answer in terms of 2, right? So let's write it over here. 2, we will get 128. In the next step, we will get 64, 32, 16, 8, 4, 2, and at the end 1. So here 256 is broken down in terms of its prime factor 2. And how many times here 2 is repeated? Let's count it together. 1, 2, 3, 4, 5, 6, 7, 8. It implies 256 can be written in the form of 2 raised to the power of, how many times we have calculated? 1, 2, 3, 4, 5, 6, 7, 8. So 2 raised to the power of 8, right? So this is called exponential form of 256. I hope you have understood how to express any number in terms of its exponents. Now let's move further and let's see what is next. So here students, the next topic is how -1 as a base behave with different exponents. So let me take an example for you. I have -1 as a base. Suppose this number is repeated 4 times. Let's do it and see what will happen. So let me write it for you. So -1 raised to the power of 4, or simply the power of -1 is 4, right? So since the power is 4 here, how many times we have to multiply 1? 4 times. So -1, -1, -1 and -1. So in the previous chapter, we have already discussed about the rules of multiplication of integers, right? So let's apply it over here and let's check what is the result. So minus minus is plus, plus minus minus, and minus minus again we have plus. So the result comes out to be +1, right? Now instead of taking power as an even number, let me take an odd number power. Okay, so let me take -1 raised to the power, let's say 7. Let me multiply -1 7 times and check what is the result. If you multiply -1 for 7 times, what will be the result? Let's check it together. So -1 into -1, let me write it for you 7 times. Right? So if you multiply this -1 for 7 times, what is the result? So apply the rule of multiplication of integers over here and check the result. So minus minus is plus, plus minus is minus, minus minus plus, plus minus minus, again minus minus plus, and plus minus minus. So my result comes out to be -1 over here. So from these two examples, we come to know that if we have odd number as a power of -1, the result is always -1. But if we have an even number as a power of -1, we will always have +1 as our result. So students, I hope you have understood this concept very well. So the next topic is laws of exponent. This is very interesting topic, students, and this is going to help you a lot in your later classes also. So here, let me tell you the rules of or the laws of exponents one by one. So let's discuss first the first rule, multiplying powers with the same base. So what we are going to do here, suppose we have a number with power a, and then again with the same base we have the same number with different power, let's say b, and we have a sign of multiplication over here. So what we will do, we will keep the base as it is. Since we have multiplication over here, what we will do, the powers get added. So I will write a plus b. So this will be my result. Let's solve it using an example. Suppose here I have 6 raised to the power of 2. Here I have 6 raised to the power of 3. So 6 raised to the power of 2 is getting multiplied with 6 raised to the power of 3, right? So here I have the common base, I have the same base, right? And I have a multiplication sign over here. So let's apply the rule of multiplication of exponents. So here write the base as it is and add the exponents. So here 2 plus 3. So what you will get? You will get 6 raised to the power of 5. So this is my required result. So this is the first law of exponents. Now let's move on to the next law. Let's see what is that. It is dividing power with the same base. Now what we are going to have it here? See, let's take an example to understand this law. Suppose I have 8 raised to the power 7 and I have to divide it by 8 raised to the power of 4, right? So this law states that whenever you have number with the same base but different power and having a division sign, in that case keep the base as it is and the powers get subtracted. So what I will write? I will write 8 raised to the power of 7 minus 4. So what I will get? 8 raised to the power of 3, right? So this is my required result. So I hope this law is very much understood by you. Now let's move on to the next law. Let's see what is that. Next is finding power of a power. This is very, very interesting and I find it easy too. Okay. Now let's take an example to understand this. Suppose I have 2 raised to the power of 3 in one bracket, and then outside I have one more power, that is say 2. So how we are going to solve it? The law states that if you have a raised to the power of m raised to the power of n, where m and n are integer, in that case the powers get multiplied. Okay. So since I have taken this example, let me apply this law to this example. So here 2 raised to the power of 3 into 2. So what I will get? I will get 2 raised to the power of 6. So this is my required result. Understood? Let's move on to the next law. Let's check what is that. Now the next law is multiplying power with the same exponent. So initially we saw that we have the same base but different powers, right? Now here we will see different bases with the same power. How we are going to multiply it? So let me take an example for you. Suppose I have a raised to the power of m, one number in the exponential form, and let's say I have b raised to the power of m, again in the exponential form. So how I am going to multiply this? So simply what I will do, I will multiply the bases together and I will keep the exponent as it is. Okay. So let me apply this law to a question. So let's say I have 2 raised to the power of 3 and I have 3 raised to the power of 3. So as you can say that we have taken same power but the bases are different. So let's apply this law to this question. What you will get? So simply what you have to do, you have to multiply the bases, that is 2 into 3, and keep the exponent as it is. So I will write 3 over here, right? So if you multiply these two, what you will get? You will get 6 and 6 raised to the power of 3. So this is my required result. So I hope this law is also clear to you. Now let's move on to the next law and see what it says. So the next law is dividing powers with the same exponents, right? So let's take an example to understand this. Suppose I have a raised to the power of m, okay, and it is divided by b raised to the power of m. So here the bases are different but the powers are same and the operation is division. So what you will do in this case, you simply divide the bases and keep the exponent as it is. So in order to understand this law, let's apply this law to a question. Suppose I have 4 raised to the power of 2 divided by 2 raised to the power of 2. So here the bases are different but the exponents are same, right? So I will write 4 divided by 2 and I'll keep the exponent as it is, that is 2. When you divide it, what you will get? You reduce it and you will get 2 raised to the power of 2. So students, this is my required result. So I hope this law is also clear to you. Now let's move on to the next concept. So the next concept is next law, that is numbers with exponent 0. So what does it mean? Exponent 0. So it simply says that whenever you have a number, let's say 4, and it has a power of 0, its value always comes out to be 1. It doesn't matter how bigger the base is. If it is having a power of 0, then its value will be 1 only. If you write 1000 raised to the power of 0, then also its value remain the same, that is 1. So I hope this law is also clear to you. Now let's move on to the next topic and let's apply these law to a complex problem. Let's take this problem, okay? Now let's see what is there. Here 6 raised to the power of 2 raised to the power of 2 divided by 6 raised to the power of 4. We have this one in one set and this is multiplied with 6 raised to the power of 2. So here, first of all, in order to solve this, we will solve this bracket. So here this is power of a power rule. So what I will do, I will simply multiply both the powers. So 2 into 2. 6 raised to the power 4 will remain as it is and 6 raised to the power of 2. When you solve it, you will left with 6 raised to the power of 4 divided by 6 raised to the power of 4 into 6 raised to the power of 2. Since this is division, bases are same, what you have to do, you have to subtract the powers. So what you will get, 6 raised to the power of 4 minus 4 into 6 raised to the power of 2. So you will left with 6 raised to the power of 0 into 6 raised to the power of 2. So as I've told you, any number having a power of 0 having a value 1. So I will write 1 over here, 1 into 6 raised to the power of 2. So what is the result? 6 raised to the power of 2. And what is 6 raised to the power of 2? It means 6 is multiplied 2 times. So what is your answer? Your answer will be 36. So students, I hope you have understood all the laws and I hope you understood how to apply these laws to different problems. Now let's move on to the next topic. The next topic is expressing large numbers in the standard form. Okay, so at the beginning of the chapter, I told you there are big numbers which are difficult to read, which are difficult to deal with, which are difficult to compare and which are difficult to apply any operations on this number. So we need exponents so that we can express or read these numbers, right? So let's take an example over here. Suppose I have 93 into 10 raised to the power 6 using decimal that we have just finished, right? In the previous session, using decimal representation of any number, let me write this as 9.3 into 10 raised to the power 7. So writing the number in this form is known as standard form or scientific notation, right? So we simply express any number in terms of x into 10 raised to the power of m, where x is any number between 1 to 10 and m is any integer. So this form is called scientific notation of any number. So let's take an example. Let's see how we can express any number in scientific notation. So here the first number is 8 lakh, right? So let me write it for you. What I told you, you have to put the decimal reading from the leftmost digit and putting the decimal just after the first digit. So what you will write? You will write 8.0 into 10 raised to the power, how many zeros we have? 1, 2, 3, 4, 5. We have 5 zeros. So I will write 8.0 into 10 raised to the power of 5. So this is the scientific notation of this number. Now let's take another example. Let's take this number. So simply what you have to do, put the decimal after 8. So 8.54 into 10 raised to the power. Just count the number from the right. 1, 2, 3, 4, 5 and 6. So I will write 10 raised to the power of 6 over here, right? Now let's take another example. Here 2, 8, 9, 4, 0, 00, 000. We have this number. In order to express in scientific form, what you will do, simply put the decimal after 2. So you will get 2.894 and then count the numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 numbers after decimals. So I will write 10 raised to the power of 9. So 2.894 into 10 raised to the power 9 is the scientific notation of this number. So I hope students you have understood the topics that we have covered in this lecture, like what are exponents, why we need exponents, the laws of exponents, how to apply laws of exponent to simplify expressions and the standard form of any number. So that's all for today's session, students. We will meet you in the next session. Till then, take good care of yourself. Keep smiling, keep learning, keep practicing.